Okay, students, we're going to talk about dilations here. Go over this worksheet and you'll have one similar to it, different numbers. All right, so write down this information you see here. Dilations preserve. The two main things they preserve are angle measure and parallelism. For this worksheet, parallelism is a key thing. That means all corresponding sides are parallel. What does it mean to be parallel? They have the same slope. So when we write the equation lines, we're not going to change the slope no matter what. The only thing that may change if the center of dilation is not on the line itself is the y-intercept. So let's go ahead and start with number one. The line negative y equals 5x minus 5 is transformed by dilation center at the origin. That's the key right now. Which could be its image. Okay, well that means we have to have the same slope. The y-intercept doesn't matter, but the slope has to be the same. Well, one thing that you may or may not know, the slope is determined by the x and the y terms. Notice, so I need these to be the same. So notice the format they're in this multiple choice. It's x and then y. So I need to go ahead and move this x across and it becomes negative 5x minus 1y. So the only one that says negative 5x minus y is A. Yeah, so B says, oh, sorry, negative. Yeah, because B says a negative and negative, which is positive. Yeah. Okay. So our answer is A. Doesn't matter about the y-intercept. As long as the slope's the same, then it's parallel, and therefore it's a dilation. All right, number two. First thing we want to do is, when it's not centered at the origin, as this is not, it's centered at 1, 1, is check to see if that point is on the line by plugging the 1 in for the x and this 1 in for the y. If it's true, so I'm plugging it in here, if it's true, then the point is on the line. And if the point is on the line, so if the center of dilation, which is the 1, 1, is on the line, then the dilated line remains the same as the original. So I plug this in, I get 3 times 1 is 3 minus 2. That's what you see here, 3 minus 2, that equals 1, which is what my y-coordinate says it's supposed to be. So that 1, 1 is on the line. So it remains the exact same equation, y equals 3x minus 2. That's 1.5. For the scale factor, did not matter because the center of dilation was on the line. Number 3, I need to pay attention that this is not in slope-intercept form and rewrite it if I wanted to, like this. Okay, it's transformed by the center at the origin. That's good. So the slope remains the same. So that means this whole piece that's going to deal with the slope is the same. The only thing that's going to change is the y-intercept. So I take the scale factor, SF is scale factor, multiply it by the y-intercept of 3, and that gives me 1.5. So there's my answer. For the slope, negative 3 does not change. All right, number 4 is also dilated at the origin. Okay, so I go ahead and solve for y. Solve for y, I get y equals x minus 1. Okay. And it says scale factor of negative 4. So I take that negative 4, multiply it by that, and I get y equals x plus 4. Okay. Because remember, the slope does not change. So this piece remains the same. Y equals x remains the same because slope is 1 still. Just as here. It's only the y-intercept that's changing. That's going to be true for all these lines. Okay. The part that may change is the y-intercept only. The slope must remain the same because it's parallelism property. All right, now this is different because this is centered at 0, 1. It's no longer at the origin. It's already solved for y for me. So I have that. If I want to put in slope-intercept for me, y equals negative 2x minus 1. But now it's centered at 0, 1. Okay, so first off, it's got to be parallel. Okay, and so it has to start out with y equals negative 2x for my answer. I'm having to find out what the y-intercept is. Okay, so if I have a line here, negative 2x, oops, minus 1. Okay, it's going to be that line right there. and it's centered at 0, 1. Okay. So now to find my y-intercept, I ask myself, how far does it take for me to get from the center of dilation, 0, 1, to a point on the line? I know it has to cross at a corner. Well, that's just 2 down. So I went down 2. To go from the center of dilation to any point on the line, that's a scale factor of 1. Remember, I want a scale factor of, what is this? 3 there. I want a scale factor of 3. Okay, so that's 1. Right there, I go down 2 more again. That puts me there. It's a scale factor of 2 now. I go 2 more again, and now that's a scale factor of 3. Right there. So what is that y coordinate? 1, 2, 3, 4, 5. Okay, so that's how I apply this. Okay, the slope part remains the same. So the y equals negative 2x cannot change. They have to be the same. It's only the y-intercept that changes. All right, here we go again. Rewrite it in slope-intercept form. So I get y equals negative 4/3 x plus 5. Again, this is not centered at the origin. It's centered at 0, 3. Okay. So I can ask myself, how far is 0, 3 from 0, 5? Remember, this is going to cross the y-axis at 0, 5. Okay. And my center is 0, 3. So how far did it take me to go from 0, 3 to 0, 5? I went right 2 plus 2. That's a scale factor of 1. So every time I go plus 2 again, that's another scale factor. So it's going to now put it at 0, 7 for the next one. But I want, that's only a scale factor of 2. I want 3, so I have to go 2 more, which now puts it at 0, 9. So the y-intercept is 9. So my equation, y equals negative 4/3 x plus 9. Okay. Some of these I'll even end up graphing, but I haven't had to yet. You can graph all of them. I've got graphs down here. The line, this, okay, is dilated the origin by scale. Okay, so this one's at the origin. Oh, it's dilated at the origin by a scale factor of 3, centered at 3, 2. There's an error. So it's not dilated at the origin. Is scratch that. Dang it. Is I should have said is dilated. Get rid of at the origin part. Just by a scale factor of 3, centered at 3, 2. What's the new equation? So first off, I'm going to go ahead and put this in slope-intercept form. Y equals negative 3/5 x plus 9. Okay. So I'm going to go ahead and graph that down here. Plus 9. So go down 3, right 5. 1, 2, 3, 1, 2, 3, 4, 5. Down 3, 1, 2, 3, 1, 2, 3, 4, 5. Okay. It is centered at 3, 2. 1, 2, 3, 1, 2. Okay. And it wants a scale factor of 3. Okay, scale factor equals 3. So I need to figure out how long it takes me to get to one of those 3 points. I'll just go to I'll change it so you can see it, the green one here now. So I'm going to go up 1, 2, 3, 4, plus 4, right 2. Remember, to get from the center of dilation to one of those points, that's a scale factor of 1. So I need to do it 2 more times. 1, 2, 3, 4, plus 2. Okay, up 4 plus 2. That's a scale factor of 2. And now I need to go up 4 more. That's 10, so I'm up to 14. And then over 2 more puts it at 9. So 9, 14 is that point. Okay, it took me off the graph, off the grid. I went up 4, right 2. Scale factor of 3. Okay, so 9, 14 is a point on the line, and I know the slope stays the same. Slope is negative 3/5. So I'm just gonna, I'll do the work there. So I'm going to put it in point slope form. Y minus y sub 1 equals m times x minus x sub 1. Remember, that's point slope form. So there's my x sub 1, y sub 1, and my slope, negative 3/5. So I have y minus 14 equals negative 3/5 times x minus 9. Okay? Now, if I want to go ahead, that's an equation of a line right there. So that would be a possible answer. On the DCAS, oftentimes they'll have you put it into slope-intercept form. So how do I do that? I need to solve for y now. So I want to get rid of the fraction. First off, so I don't have to deal with fractions. So I'm going to multiply the entire equation by the common denominator of 5. So now I have 5y minus 70 equals negative 3 times the quantity x minus 9, because the 5's cancel. Now I go ahead and distribute that 3 through there. I get negative 3 through there, man. Okay. Now I go ahead and add the 70 across. And lastly, I divide by 5 on each term. And now I'm in slope-intercept form. So that equation is y equals negative 3/5 x plus 97/5. Okay, notice my slope came out to be exactly the same, because it should. And it does. Remember, parallelism is preserved. Okay, so there's that answer. So it's a little more work when if it's not on the origin and it doesn't go through, or it's a long distance to get to different points there. All right, so let's go to the next one here. Change that to y slope-intercept form. So that's going to give me y equals 4x plus 2. Okay, dilation is centered at 3, 3, scale factor of 2. So if I go ahead, 4x plus 2, 1, 2, 1, 2, 3, 4, 4x plus 2. Okay, and it's centered at, what was it? 3, 3. 1, 2, 3, 1, 2, 3, right there. Okay, we'll change that color to red. There's my center dilation. So I have to go down 1, left 3. That's a scale factor of 1. Down 1, left 3. 1, 2, 3. There's a scale factor of 2. That's what we were looking for, right? Scale factor 2, yes. So it is this point right here. What is that point? Negative 1, negative 2, negative 3, 1. That's my x sub 1 comma y sub 1. Okay, so now my slope doesn't change. So I already know it's y equals 4x. So I put in point slope form, y minus 1 equals the slope 4 times x. Is that a negative 3? Yeah, so minus a minus 3 makes it plus 3. Now it's not very hard to change it into slope-intercept form because there's nice all integers. So that gives me 4x, that's plus 12, and plus 1 is plus 13. Is that new equation with scale factor of 2. Okay, now I need to erase that, so you can obviously pause the video if you need to. Okay, so 9 and 10 are on your own. That deals with angle measures. Okay, backside now. So I've gone ahead and done some review on this backside with the dilations, but I also wanted to check your rotation, translations, etc. The transformations put together with this. So you're reviewing your rules, and I want you to write down the rule for each one, whatever that rule is on the problem. So if A is negative 2, negative 1, then after a dilation of 3, now if it says that, it's automatically at the origin. So therefore, I just multiply each coordinate by 3. That's it. That gives me negative 6, negative 3. Very easy. Here, we're going reverse direction. A prime is that. Then after a dilation of 3, what was A? So now I'm going backwards. So I'm having to divide by 3 on each of those, and I get 5, negative 1. I could therefore go forwards to check it. If I do that, do a dilation of 3, multiply those by 3, I do get the 15, -1. Number 3, there's A and A prime. What's the constant of dilation? So sometimes I'll call the constant of dilation is the scale factor. Scale factor equals constant of dilation as well. So remember, it's image over pre-image every time. Oops, pre-image. So I can take either coordinate. 28 divided by 7 is 4. Or I could have done 4 divided by 1 is 4. I get the same answer. All right, the 0.06 is rotated. Oh, we've got this over here. So the same idea here. Image divided by pre-image. So 8 divided by 56 is 1/7, which I could have got -1 over -7 is 1/7. And that's a reduction. Remember, it's reduction. It's between -1 and 1, and it's an enlargement here because it's greater than 1 or less than -1. All right, next, the 0.06 is rotated 90 degrees about the origin and then dilated by a scale factor of 5. Again, that's from the origin. So rotation of negative or 90 degrees, it's a reflection over the x-axis, which is the y, to negative, and I switch the x and y coordinates. So I want you to write down the rule and now apply it. So that's going to make it negative y is -6, 0, and then dilate that by 5, which makes it -30, 0. All right, 9 zeros rotated 180 degrees. That rule is -x, -y. Again, you're supposed to have these memorized. Quiz each other in decast sheets. So that makes it -9, 0. And then we're dilating it by 3. So -27, 0. All right, the 0.30 is rotated 270 degrees. Dang, there's a lot of zeros in here. Randomly came up with a bunch of zeros. Rotated 270 degrees. Remember, that's the same thing as our rotation of -90 degrees, which means reflect over the y-axis first, makes it -x, and then switch the y and the x. So there is the rule for -90 degrees or positive 270. Apply that, y, which is 0, -x, -3, and then dilate that by 4, makes it 0, -12. There's my answer. The 0.37 is reflector of a line y equals x. What's the rule for that? Reflector of y equals x, it just becomes y comma x. So just switch them, 7, 3, and then dilate it by 6, makes it 42, 18. Okay, so if you know in your rules, this should go by quick, and it's making you have to review rules for the DCAS as well. Reflector of a line y equals -x. That rule is -y, -x. So I apply that, and I have 2, 4 now, and a dilation of 3, which makes it 6, 12. Okay, it's a reflector over the x-axis, which just takes the opposite of the y-coordinate. So now it's that. It's a scale factor of 5, dilated by a scale factor of 5. So it's -10, -35. So one is a reflector over the y-axis that switches the x-coordinate, and then scale factor of 6, so multiply it by both coordinates by 6, you get -42, 6. The point -2, -3 is a reflector of the line y equals 2, and then dilated by a scale factor of 5. What's the resulting image? So this has got no rule. This over the line y equals 2. So I have to actually plot this now. So I'll use this graph down here before I have to use it for 14. So y equals 2, I have to know that's a horizontal line at y equals 2. I'm reflecting -2, -3 right there. So that's a total of 5. So I have to add 5 to it. 1, 2, 3, 4, 5 right there. So that is -2, 7. Okay, so I've done that. Then I take that and dilate it by a scale factor of 3, which is -6, 21. -6, 21. Okay, now we get down to the last two. Graph the segment AB, negative 3, 3, negative 1, 2, 3, 1, 2, 3. There's A. And 4, 2, 1, 2, 3, 4, 2 right there. B. Connect them. Okay. Then dilate with a scale factor of 0.5. Okay. So since it doesn't tell you where it's centered at, it's automatically centered at the origin. So I just take 0.5 of each of those coordinates. So that's going to be 2, 1, 2, 1. Oops, change it to a color. 2, 1 then, that's B prime. And negative 1.5, 1.5. Negative 1.5, 1.5 is A prime. Connect those. Okay, and that is exactly half of the original. I could guarantee I'm right because if I go ahead and go through the A and A prime, it'll take me to the origin, and B, oops, B and B prime, they intersect at the origin, which is the center of dilation right there. Okay. Segment negative 4, 4, 1, 2, 3, 4, 1, 2, 3, 4, oops. 1, 2, 3, 4, 1, 2, 3, 4, 4. There's A. 2, 2, 1, 2, 1, 2. There's B. Okay, and it wants a scale factor of 2, centered at 0, 1. There's 0, 1. So I go out to each of the endpoints. How do I get to the endpoint? Up 1, right 2. So I must go. Okay, I just want to erase that one. Put the B down here. Up 1, right 2. So I go up 1, right 2. That's a scale factor of 2. Up 1, right 2 to the B is the original scale factor of 1. I do it again, it makes a scale factor of 2. So there's B prime. How do I get to A? I go up 1, 2, 3, and 1, 2, 3, 4 to the left. So I go up 3, 1, 2, 3, 4 to the left. 1, 2, 3, 4. Right there is A prime. Then I go ahead and take my ruler and reconnect those. And they should be parallel. Okay, that's slightly off right there. Okay, now they look fairly parallel and it should be twice the length. And of course, I could sit there and go from A prime through A. It should take me right back to the center of dilation, and from B and B prime, and that should take me right back to the center of dilation. I guarantee that I plotted those points correctly. Okay, that is it for both sides.